And this is telling you a bit of a story, and it came to me with a bit of an epiphany a couple of months ago around the difference between a good application job and a poor application job. What I've got here is a waterfall chart. So there are various aspects here. So if we're dealing with the baseline potency of an NPV, if we just pick that as being 100, when we go through and we select out of the thousands of different isolates that we work with, we select the ones which have the higher levels of efficacy. We can actually get an increase over the general wild NPVs to a small degree. So we can actually increase the efficacy above. Then there's some jiggery pokery that we do with the manufacturing process, and you can potentially add even a little bit more with this. However, when we go from a laboratory formulation to producing millions of caterpillars, there's always some kind of a penalty with the performance. And this is partly to do with some of the things which happen with caterpillars when you mass rear them. So there's always going to be a bit of a loss. Whenever it's stored or transported, sometimes it gets a little bit warm. There could be a small drop in performance. When you've got a poor application job, and I see the aircraft here laying a cloud of droplets on top of the plant, which is great for any exposed surface, but any entrenched larvae are not going to get it. So there's a pretty significant penalty. There's pretty significant penalty to be had by having poor droplet size. And if you're laying it on top of the crop as well, you further get another penalty here. So you're not getting at those entrenched larvae. If you're using a pH of 8 water, there will be a loss as well. But if you add an adjuvant, you can actually improve. And this is the waterfall effect here. UV light is the worst villain for breaking things down. You can lose some more. Field humidity with a crop like that, you lose a little. Field temperature, it's hot and dry. You're going to have synergistic pathogens out there which are going to assist you with. So you're going to get a bit of a free ride with some of them, the metabolic toxins, and if there's any residues of chemistry which are out there, you're picking up some. But the big one here with any of these things are the number of beneficials which are out in the field. So at the end of the day, you've got control pretty much from when it goes in the tank until such time as it ends up inside a caterpillar. But you have you don't have any control over that period as a manufacturer. If we were to turn that application job into a perfect application job, keeping these variables all exactly the same and potentially running it through an overhead irrigation, these are variables all exactly the same from above. The droplet size is the same. The location of the plant is ideal. We could have a slightly alkaline water. The adjuvant effect, there is none. The field humidity is good, as is the field temperature. The exact same job, with the only variable being good and crappy application, is a significant difference at the end of the day. So I just thought I'd like to flag this process around the cascade of poor application job. Yes, I put on 300 litres of water to the hectare. Well, that's good and well. What was your coverage actually like? As compared to, look, I only got 150 litres on, but I got fine droplets and I didn't have any drift, etc., etc. So that's just something we would just like to flag, that the difference between a good application and a poor application can be really quite significant, particularly when the beneficial insects are in the crop and they're doing all the hard work for you.